Very good morning to all of you. Today we are at lecture 5 of concept engineering EL5 section. So what is the topic? Block diagram algebra and reduction technique. In continuation with the previous lecture, what we have consumed, what are the techniques of block diagram? What are the different parts? What are the signal involved with each block that we have already discussed. Now, what will be the block diagram algebra? Because ultimately what you have to obtain a single block associated with the excitation and the final control variable as output. Set point as the input and control variable as the output. That's why we require some algebraic manipulation. So this part involves block diagram algebra and the reduction technique such that we may get a single block associated with the RS means set point as input signal and the excitation and the output as the response as C. Controlled rate. Okay. So moving to the topics. So what are the topics to be covered today? That is basic connections for the blocks. Individually, what are the connections may be possible in case of block diagram regionally find that will be discussed. And those connections mainly are cascade connection, parallel connections, and feedback connections. So majorly, these are involved in block diagram you can observe. Okay, as well as what are the block diagram, what are the algebras. Algebraic manipulations are there to reduce the block diagram. Before going to reduction technique, what are the algebra involved that we have to go through. Okay, now moving to the topic, basic connections for the blocks. So what we observe in case of block diagram algebra before going to start. So what are the different types of connection involved in the block diagram? Let's find. And what we found here is the cascade connection, parallel connection, and feedback connections. So mainly three type of connections are there: cascade connection, parallel connections, and feedback connections. Okay. Now, in case of so what is basically the cascade connections? What are series connection, parallel connections, and feedback connections? So we know that, but how to manipulate it, that is much more important. Okay, so that's why before going to the reduction technique of the block diagram, to get the total transfer of function of the system, we need to get each and every connections and the details, how to manipulate it, and then coming towards the block diagram. Through the block diagram algebra, we will be coming towards the block diagram reduction technique. Fine, I'm moving to the next part. See, each and every connection we what will be the detail here. Okay, so for in case of cascade, what do you mean by cascade? Cascade connection is nothing but we can say cascade is nothing but the series. Cascade means what does it mean? It is nothing but the series connections. So if there are the blocks involved, okay. So input of one block, this is output, and this output is coming as the input to the second block, and then coming as the output. So this output equals to second stage input. If this happens, then it will be terminated with series connections, right? It will be terminated as a series connection, so that will be terminated as a cascade connection. So cascade is nothing but the series connection. Okay, so there may be two or three or more blocks. Okay, so cascade connections means basically series connection that was represented over there in this diagram. So what we found there, G1 is one subblock and G2 is another subblock that we have already identified. In the control system, there are so many blocks. Okay, so in case of forward path also, in case of feedback path, we will be getting several subsystems and each will be representing to the in the blocks as a transfer function. So that's why we are getting so many blocks and so many blocks that will be connected in that will be properly placed like cascade connections, okay, or in series connections. So if it is one after another and one output of the first block is coming as input to the second one, then it will be termed as a series connection. There's a convention of the network. So we are telling this one is a cascade connection, a series connection, nothing else. Okay, not a complexity there. So first block having the gain G1 that is defined, second block having the gain, sorry, that is basically the transfer function of the subsystem that is G2. Okay, G1 is and G2 is. So Here XS is the input signal associated with G1 block, and ZS suppose is the output signal associated with the G1 block. Okay, this ZS is coming as the input to the GTS block, and then output is YS. So what will be the ultimate YS? Let's manipulate. Okay, then we will be coming, what will be the total transfer function of that combination of these two blocks, and then combining these two, we will be getting the final, what you can say, shortening this two block into a single one, converting this two block into a single one. Okay, let's see. So JDS, that will be basically, this is mainly what you can say G1S, right? So G1 is basically output, Laplace transformation of output to the Laplace transformation of input. That is the ratios while initial taking initial conditions to be zero. That is called the transfer function of the first block. This is the first block. This is the first block transfer function. So what we can say, ZS is nothing but G1 is into Xs. So while we are getting ZS as G1 is into Xs, then what will be YS? It is the input to the G2 block. ZS is the input to the G2 block. So what will be YS? YS will be equals to G2S into ZS, right? Because G2 is the transfer function of the second block. So G2, instead of G2S, I am writing in G2, right? So you have to write G2S. So what you are getting here, G2S is nothing but YS divided by ZS, right? So here, YS, that is the ultimate control variable of that system, that is YS equals to G2S into ZS. So now YS, we are using G2S into ZS, right? Now, as we know, ZS is equals to G1 S into XS. So, putting this one, what we will get? IS equals to T2S, G1 is this. Now, what we find? These are two gains. Okay, consecutive to block having two gains multiplied with each other. That is output, and this is the final output, and this one is the excitation. Right? So what we are getting, G1 is into G2S into X. So leaving excess, so we find that we have G1 is multiplied with G2S. That is the transfer function. If we say YS is the output and XS is the Laplace transformation of input. So the final transfer function, what we find, YS by XS, that we are getting G1 is into G2S, right? So that's why if one say that I am drawing a single block with the gain with the transfer function, yes. So what you will get? You will get Q1 is into. Okay. So the final manipulation is there. That is the transfer function we are putting in a single block, having with the input as XS or excitation as XS and YS as output. So what we get, XS equals to G1 is into G2S into XS, that will become YS, right? So that has reflected over there. So one can say if there is two or more than two blocks, then we will take this block diagram of multi-stage into a single stage by applying the uh, equation of the series, of the concept of series network or the cascade network. And what we have manipulated finally, we have manipulated that if the blocks are in series connection or cascade connection, then the simplified block having the conjugate block having the transfer function, that will be the multiplication of these two things. Okay, so the transfer function of a single block is the product of the transfer function of the individual blocks, right? Individual block. So we can say here, this is the manipulation, this is the calculation behind this one, manipulation or calculation behind this that simplified diagram or reduced diagram. Better you can say reduced diagram. Okay. So in this way, we are getting for the cascade connection, what you have to keep in mind? You have to keep in mind that whatever be the number of blocks, just put into multiplication of those transfer functions, and final transfer function will be the product of all those transfer functions, and we are putting just the input over there as a set point, and here the desired input, desired output, and here the control variable only. Okay, so input and output and associated with a single block with the gain of product of all those transfer function. If these blocks are in series or test connection, right? Now we are moving to the next part. See, let's see. Now what we have the connection, this connection, moving to the parallel connection. So you have to first identify what is the parallel connection, right? Very simple. Parallel connection means what? Like your concept of circuit theory, what you have in case of there are so many resistances. Parallel connection means all the input end will be connected shorted. Similarly, output end will be shorted. Okay, then we are getting here all the combining all those resistors having only the two terminal. One is the input terminal, another one is the output terminal. This is nothing but the parallel function. Okay, so where we are getting the voltages all are equal for those components, right? That is called the parallel connection with respect to circuit theory. The same is here. Concept is same everywhere. Okay, so instead of single element, we are having here the blocks, having with the gain, transfer function, sorry, having with the transfer function, G1s and G2s, or the two blocks I have represented over here. I could identify, as you know that the takeoff point is the point where the same signal will be branching off into different subsystems. It is going towards the subsystem G1 as well as G2. So same signal is here at input. G1 is as well as at G2 is also at this system also, subsystem also. Okay, and then output will be the combination of these two with the phase consideration. Okay, so what we are getting YMS and YTS. So it is combining also at the summing point. It may be vice versa. But what we are getting that same symbol is getting over there, and we are getting the combination of these two as output. So G1 and G2 are one parallel block, parallel combination. Okay, parallel combination is there. So what will be the manipulation in that case? See, while x is passing through G1 with the transfer function G1 is of the system, so we are getting Y1 is. So what is the expression of Y1? Y1 is having the expression obviously gain multiplied with the gain, sorry, transfer function multiplied with the input. It is transfer function. So G1 is into x, right? Because G1 definition according to definition of G1 is that is basically Y1 is by xs. So what we are getting Y1 is equals to G1 is into x this time. Now what is Y2s? Similarly, x is also passing through the 2. So what is Y2s? Y2s is gain as sorry transfer function of that block G2s into x. So we are getting G2s into xs as the Y2s. Fine. Now these are what is the phase will be same, and this is summing up at the summing point, right? So both will be summed up, summed up. Okay, addition will be taking place with respect to their phase. So what we are getting y is control variable continuity that will be equals to y1 is plus y, right? So y we are getting here g1 is into xs plus g2 is into xs. That's why xs is common factor. So taking common. So what we are getting g1 is plus g2 is into xs. Fine. So compare this equation with the standard form. So what we get? Y is equals to gs xs. So if one write only a single block for this system, so how could you write it? GS, what is the manipulation? What is the expression behind this GS? Nothing but G1 is plus G2S, right? G1 is plus G2S. Okay, so we are getting GS equals to G1 is plus G2S. Fine. So the combination of these two is nothing but not a product, it is a summation. Or according to the phase, if it is in negative phase, then what will become? It will become, if it is the negative one, then what will become? It will be negative. Okay, but in that case, there is a difficulty. So I will be talking about in the next slide. Okay, so in parallel connection, generally what we get here, if the transfer function, both the transfer function having with the positive signals, both the systems having with the positive signals, so we are getting G1s plus G2s. Okay, so according to the phase they will be taken into consideration. So when the blocks are in series in the previous slide, what we got the concept, the individual block with the transfer function G1 and G2, then that will be multiplied for the overall transfer function. But in case of the parallel connections, while the blocks are in parallel, then what will be the combination? Combination will be addition and subtraction. Addition or subtraction. Okay. So in this way, we can combine these two blocks into a single one. But what is the expression we need to use for the transfer function? What is our transfer function? That's nothing but the summation of these two. Summation of these two. Now, moving to the next slide. So what we have for the feedback connections? In case of feedback connections, there are two types of connection. One is a positive feedback, another one is a negative connection. Okay. Now, obviously, so see this diagram. What we have here, xs is the input, right? And that is basically the set point, and ys is the control variable output. Now, this ys is feeding back through the what you can say. This is the feedback input, which is see the direction. This is the forward path, starting from the set point to the starting from the same set point the controlled variable, right? So this is basically forward. Adding with the gain factor, that is basically the transfer function. And this one is starting from the control variable to the set point, that is nothing but it will be transfer into that, right? So here, what is the gain involved? What is the transfer function involved? Hs. What is the transfer function for the forward path? That is basically gs. Okay. So here, following figure, you can see what is the feedback taking place over there, because signal is negatively coming phase opposition. That's why it is a negative feedback. So in case of negative feedback, what we have here, the final output, if it is the signal Bs as feedback signal, so we are getting Xs minus Bs as the final output is coming as Bs, right? That will be multiplied with Bs. So this is nothing but the feedback part. Keep it in mind. But in case of the previous slide, let's see, in case of previous slide, what we had? We had both are coming from the set point to the control variable. So that is the parallel connection. Similarly, it may be reverse. Both will be coming from the control variable towards the set point. That will be considered as feedback as well as parallel. Feedback as well as parallel connection. Okay. So moving towards the next one, what we were talking about, that is the identification of the feedback. So we have identified this one is the feedback while it is coming back, that means from the control variable towards the set point, that is called the feedback. Fine. So here we have the two blocks. But what is the manipulation? Manipulation has done already in the feedback amplifier, and you very well know that you can manipulate in a very easiest manner. So what is the manipulation? Let's see. There's a calculation behind that. See, what is YS? Y is basically the direct input to this process, that is basically GS. So GS is the transfer function. So we are finding YS equals to ES into GS. Fine. YS equals to ES into GS. Now what is ES? ES is nothing but XS minus DS. Right? XS minus DS. XS minus DS, that is DS. Okay, XS minus DS. So what is DS? YS is coming here, branches off from the state of ion. It is passing through HS. So DS we are getting here, that is YS into HS, right? And that is the output of the feedback network, that is DS. Okay. So here HS into YS, that is basically DS. So XS minus DS, that will be DS. Fine. And then YS equals to US into GS. Fine. Then what is the manipulation here with consideration of the feedback network? See, XS minus HS into YS, then multiplied with GS, that is the equation telling us. So that's why we are just taking all values in common. So what is it? 1 plus GSHS, that is equal to XS into GS. So final output is YS and excitation. So it says, so taking the ratio of the Laplace transformation. So we are getting the final expression for the feedback loop, that is GS divided by 1 plus GSHS. Okay, that is called the total transfer function of the system involving the feedback network and feedback in the transfer function Hs. And if it is positive, negative feedback, then what we are getting? What we are getting the expression ES equals to BA minus BS for the negative feedback. But if it is positive feedback, then what we'll get? We will get positive, right? Then let me clear all these things. See, in case of negative feedback, we are getting this one. In case of positive feedback, we are getting this one. So this expression will be a little bit changed, and we will get here negative and we will get here negative, right? So for the positive negative feedback we are getting plus, and for the positive feedback we are getting negative. Okay. So in this way we will get this expression also for the positive feedback. So this sign will determine, okay, so this sign will determine it is the negative feedback or positive feedback. But this is the indication where the signal is coming from the output towards the input, that is the feedback. Keep it in mind. For feedback path and forward path is very important. Okay? So feedback path is the calculation is totally different. It is not summation, it is not addition, or it is not multiplication that is done in case of series or parallel. So you have to identify also the feedback. Okay. These are main three connections involved in the block diagram. So what we have finally at the total transfer function GS by 1 plus GSHS. So XS is the input and YS is the output. So in this way you can just draw a single block of the, and this loop of that is in the block diagram, that may be easily simplified to a single block with again GS by 1 plus GSHS. XS is the input and YS is the output. In this way. Now let me clear all these things and moving forward. So what we have here, let's see, block diagram algebra for the summing point. Now there's a simple manipulation for the summing point also. See, there's a convention while summing point we are observing that if while we are going to the numericals, so if it can be taken place such that the summing point that may be what you can say a shift towards the left, towards the set point, that will be easier for the calculation. That will be that is from my experience. I am telling you, and obviously it is you may take as a trick for the calculation purpose, okay, or the solution purpose. Okay. Similarly, while there will be the taking, so the takeoff point, so your projection will be that the takeoff point should be towards the, you should move the takeoff point towards basically the output, that means control variable. That's why in that case you will get a simplified solution and in much simpler way. Okay. So while you are getting the summing point, your objective is you should shift the summing point towards left. While you are getting the takeoff point, you should sometimes most of the times, you may shift that takeoff point towards the right, and then your solution will be easier. Okay, just note it down. And so that's why I am talking about this topic, that is the two possibilities of shifting of the summing point. So that's why we are making that point. Shifting of the summing point is required sometimes. Okay. So shifting of the summing point, that may be after the block, that may be before the block, according to the need, according to the problem need. Okay. So that's why the summing point that may be towards the right shift, towards the left shift. I mean, with respect to certain block. Okay. Let's see how summing point will be shifting and how the manipulation will be done. So first, let us discuss regarding the shifting of summing point after the block. So let's identify what is the topic. Okay, shifting the summing point after this block. That means we are shifting this summing point after this phase. Okay, that should be our manipulation. So how it will be done? Let's see. Okay, so problem identification done. That is shifting. We are shifting the summing point after the block. That is, we are shifting this point A after this block, and that will be your order. Fine. So, considering this block diagram, so what we have ultimately, if it is the summing point, RS is the input and SS is the another second input is coming. So RS plus X is in positive same place. So we are getting here the output will be YS equals to GS into XS plus X. Right? So we are getting the output GS XS into XS plus RS. So finally we will get this two parts. Okay, as output having with the dependencies on RS and XS, but with the common multiplication of the GS. That is your equation number one. It's very much important. Okay, so we are in my all sketch and we are moving towards the next slide. Let's see. So, see, so why we have shifted? So why we have shifted the summing point towards the left? Okay. So what we get towards the after this block? So what we get? Summing point. So this is the manipulation. Okay. So see, RS, this one is GSRS, that will automatically come. But as it has shifted here XS, so there is no manipulation. Okay, there is no multiplication with GS. Then what will happen? So you have to multiply first with XS, then just sum it. Then you will get the same result, GS RS plus XS GS. But if it is coming plain and simple with XS, so we are getting the wrong result. We will get only this part. See, we will get only RS GS. Okay, there will be no GS for XS, so we are getting only this part. Okay, so for this equation 2 is correct, but we need this equation. We need to implement this equation number 1. Okay, so let's see what is the manipulation done in the next part. See, prior moving towards the summing point, XS has multiplied with GS, right? So that's why that GS should have to have incorporated with XS. So XS should come through GS and then GS XS, that term will made, and then that will be summed up. We are getting YS. Okay, so comparing this equation number 1 and 2, so we have incorporated the second part where GS multiplied with XS. So we are getting here the output, that is the desired result, that will be equals to GS, okay, that is into RS, that is coming to the forward this part, path number 1, and from the path number 2, so what we get here, that is GS into XS, that is the equation number 1 that has accomplished. So to shift the summing point after this GS block, what is the manipulation? Signal is coming same, so you have to multiply with GS, so there should be a bin block of GS, transfer function, and then that will be summed up, we are getting YS. Okay, so this is the manipulation. So let's again see what was that in the previous law. In the previous law, this is the summing point. And after that, you have the manipulation XS multiplied with GS. Okay, that is just note it down. So we have here GS multiplied. That is the modification we did. Okay. Now again, contrary of that, okay, shifting the summing point before the block. That means what is the problem? Problem is that we want to shift our summing point is here at the right. So we generally do it. Okay, we generally do it. So this manipulation you have to keep in mind. This manipulation is important. We generally do it. Okay, summing point will be shifted towards the left. Okay, So this formula you have to keep in mind. Then automatically you can guess the another formula that is related shifting of the summing point. Okay. So just keep in mind. This is important formula for your human. So here we are trying to shift. Our point is A here, and after the block, just after the block, that we are shifting it here. A dash. So what we get here, the output that should be RS into GS plus XS. Simple. Plus XS. Right? That should have to be accomplished. That should be kept in mind. Whatever be the manipulation, no change should occur at output. That should be the manipulation. Okay, that must have in your calculation. Now shift the summing point after the block. So if you are shifting the summing point from here to here, a dash point. So what you did actually? RS plus X is plain and simple, so it is passing to GS. So what is your YS? That is basically GS into RS plus X. Right? So that is as a whole you are getting these two parts. But see, your output should come only excess, not multiplied with GS. So what you have to do? It is plain and simple. Before going to multiply it with GS, before going to that, you have to just divide with GS. Excess should be divided with GS. So what should be the gain block over there? The gain block over there, that should be 1 by GS. So if you are putting gain block over there, 1 by GS before multiplication with GS, then it will be excess by GS. So this will be excess by GS automatically. Then if as a whole it is multiplied with GS, then what will happen? GS will cancel. So we are getting X, right? So whenever that has done in the next slide, let's see. See, excess had multiplied with previously 1 by GS, right? So we are getting this output, and then if it is multiplied with GS will cancel. We will get only RSGS plus that will be the desired one. That will be the requisite. Okay, needed. So what is the manipulation? The manipulation is very much important. You have to keep in mind this is the formula. One formula, if you keep in mind, then another one is automatically deleted. Okay. So what is the manipulation? Whenever we are moving the summing point after the block, the manipulation is the which the signal. Okay, that is coming through the divided by the transfer function. Okay, the same block having the transfer function that will be divided. Okay, so in this way the manipulation will be done. It's very much important formula for your memory. Now moving to the next part. So for the takeoff point. Similarly, takeoff point we should have to move towards what is our metric. Metric is always try to move the takeoff point towards the right of the block. Okay, that will be easier for you. So while the takeoff point is at the left side, so that should move towards the right. So what is the point? You can move towards the right, or if there is any right side takeoff point, that should move towards the left. So one, if you can remind, then another one is very easy to remind. Okay. So while shifting the takeoff point after the block, so what is this here? Excess and see RS. Okay, so it is excess. So what is excess? Basically branching off, same signal is branching off. So excess is basically RS. And what is YS? YS basically GSI, right? Because it is passing through GS. So these two signals you have to keep in mind. Excess should be RS, must have to be RS, whatever be the manipulation. YS should be GSI. So how to take? See, access to GS because see takeoff point is moved to a dash point, right? Now from A to a dash point, takeoff point has moved. Now it is automatically coming to GS. So YS becomes RS into GS. It has accomplished. Now what about excess? Excess should be RS, right? So as it is RS into GS automatically, so while we have to obtain excess, so how to do it? 1 by GS. So what will get? We will get here YS. We are getting here YS, right? ys is equal to gs into rs. Automatically, if it is divided with gs, so gs will cancel. We are getting xs as rs. Okay, so we are getting xs as rs. So that should have to be accomplished. So in this way, whenever takeoff point is moving towards the right, so the manipulation will be 1 by 2. So what you have to keep in mind, this is the important formula for the takeoff point. Whenever takeoff point is moving towards the right, that should be 1 by gs. Whenever with the signal and the transfer function of that block, that will be manipulated 1 by gs. Okay, and whenever the summing point is moving towards the left, that should be always 1 by gs. Okay, these two important formula we will be going to use for the reduction process of block diagram. Similarly, shifting the takeoff point before the block. So what is the problem now? This point A, that takeoff point is moving towards the A dash. Okay, before the block. So how can you do it? That is, obviously, what is excess? What will be excess? Here, excess is equals to ys, fine, and that is gsrs. So you have to accomplish gsrs. Okay. So while it is moving towards the left, the dash point, so rs is coming in, but you need gs. So just plain and simple multiply with gs. So what is that? S equals to basically is gs. Very simple. What is gs? But you will keep in mind only 1.2 formula. For one is for the shifting of the takeoff point towards the right and shifting of the takeoff point, the summing point towards the left. And that is manipulated with 1 by gs. That will be manipulated for both of the case 1 by gs. Okay, very simple. And thank you. And for the next lecture, please wait. I will be talking about how to use the block diagram, and those concepts of the previous class and today's class is very much important. And just shuffle all these concepts, and we will be using all those concepts in the reduction technique. And till then, thank you.